Hello. Surrounding them.
Good evening, everyone. Am I audible? Please, can anyone confirm? Am I audible?
Yes.
Welcome to day 3 of our free masterclass on mechanical product design. It's great to see you all back to learn more. Today, we are diving into one of the most essential tool in the field, SolidWorks. Without further delay, I would
थोड़ा
like
क्लास ఆడ తీసుకొస్తుంది గుడికాడ కడదామన్నా అన్న గుడికాడ
మైక్ బంద్ చేసుకోబే అందుకు
వెళ్దామని లేవా
రీబుక్ లని చూడక
there is some disturbance from your side. Rupesh, can you please mute yourself? Without further delay, I would like to hand it over to Vijay, who will take us through today's session, sharing his expertise. Vijay, over to you.
Thank you very much, ma'am. Thank you very, very much. Am I audible to everyone?
Yes, Vijay.
Okay, thank you very much, ma'am. Thank you for having me for today's session. Okay, students, very warm welcome to all of you. My name is Vijay Datta, and I am your host for the today's session. Our today topic is SolidWorks. We will delve deep into today's session, and I will share some insight more deep into the SolidWorks softwares and why all this SolidWorks software is beneficial to all of you. So first of all, let me discuss with you what do you mean by the word design itself. Basically, when you are talking about the SolidWorks software, mostly the first thing which comes to our mind is that we will use the SolidWorks software as far as the designing is concerned. But what do you mean by designing? First, it should be clear to all of us. So design means is to invent, is to plan, is and develop something for a particular purpose. That is in nutshell. It's if I am talking about the word design in the nutshell. Okay, so word design means is to plan, is to invent, is to plan and develop something for a particular purpose. It comes from an Italian word, designer. Designer is said to have meant to draw a plan. When you draw a plan, because you can only create something which you can think of. Okay, the concept has to be there. Okay, it is through. Student, please mute yourself. Student, please mute yourself. Student, please, it's a humble request from my side to mute yourself and then talk.
బాబుకి ఇప్పుడు దేవెట్టేస్తావా నిజంగా క్లాస్ అంటాం
Thank you, ma'am. Thank you. For this reason, it is thought that the word design initially means to draw something with a sense of plane on a paper. So moving further, so finally design means is to turn ideas into the reality. Whatever is the place, productivity or the system that underpin how we live our lives. That is what you mean by the word design itself. Now, how the design cycle works. Basically, if you have to design something on the SolidWorks software and any other the 3D modeling software or the or take the help of the AutoCAD software, how the complete design cycle will work. The first and the foremost thing as far as the design cycle is concerned is there should be a need or the aim. Until and unless there will be no need or aim, we can't design anything. Because for the companies who are in the market using the SolidWorks software, the intent in the long run is to make money, is to increase the profit of the organization by helping the public in general. So first they have the need has to be there, or they should have a aim. Once the need is there, or they will generate a need, the aim is there. What's the next second step? They have to analyze the set of problems. But see, they want to design something. Okay, when they will hire a team or they will create a team, and then they will start designing a thing. First and foremost thing, they have to go for the set of problems. Find out how the total thing will work out. You have to find out all the set of the problems, and the next thing, after they will figure out whatever the problems are, they will go for the set of solutions. Means a problem has many way to solve. Okay, it depends upon the technical skill of the person, his experience, and all the other things related to that. How that person is going to solve that problem. So, as an engineer, as a mechanical engineer, or as another engineer, what you have to do, you have to select the best possible solution. This is the design cycle for you. First, the need should be there. Then you have to analyze the setup problems. After you have analyzed the setup problems, you have to figure out what are the different ways by using which you can solve those problems. And then finally, you have to select the best possible solution. See, student, in this session, I am talking precisely in terms of the software. I am not getting deep into the manufacturing and the other aspects like procurement and all those things. We will discuss about each and everything which is related to the software line. Okay. So first thing is, as I have already told you, the first and the foremost things which you have to consider is that you have to go for drafting. See, actually, drafting is a process. By using drafting, what we create drawings. And what do you mean by drawing? Is the mode of the communication of the design data. Whatever the design data is there within your mind, you are going to implement that data on the piece of the paper. And the process by which we are able to create something like this is known as a drafting. Then comes the second step, that is prototyping. Okay, you have already done with your plans. You have all the dimensions and the tolerance, whatever the required. The drawing is in front of the view. You have all the views, but you want to visualize how this model look like as far as the 3D is concerned. For that process, you will go for prototyping. Prototyping, what I mean by prototyping is to create the replica of the 3D model. Replica means how the 3D model actually look like. First, we will create a plan. After the plan, when we have all the views, we have all the required dimensions. Then by using that dimensions, we will create a prototype. After we are done with the prototyping, it's mean to create the 3D model, is to create the replica of the original model. And then we will analyze, we will apply all the stress, strain. Then if you want to go for thermal, then heat will come into play. And if you want to go for multi-direction analysis, then it will be a combination of two and more things like structural and the thermal. And this is how the whole process works. First, the plan has to be there. Then after the 3D model has to be there, then the same 3D model has to be analyzed whether our 3D model is good enough to work or not. If I will face any problem as far as my 3D model is concerned, then I will go back to the drafting. It means I have to select the second best possible solution. Whatever the best possible solution I have selected, that best possible solution is not working for me. No, I will go back and I will select the second best possible solution. Then what I will do? I will again make changes to my plan as per the new selected option. Then I will make changes to my prototyping, the 3D model. Then I will again analyze up to the point I will get the desired result. This whole process will go on and until unless I will get the desired cycle. It means you have to plan, do, check and act. Plan, do, check and act. Plan, do, check and act. It's more like of a PDC cycles. You have to repeat the same thing again and again until you will get the desired result. So starting with the first thing is the drafting. See, student, why I'm focusing on this thing, I have shared with this PPT with you, so that you must have a fair idea of what's the importance of the SolidWorks software and why we have to use the SolidWorks software. So first process is drafting, as I have already told you. Drafting is an act and discipline of composing drawings that communicate how something functions or is to be constructed. It means if the design is a concept, then drawing is the, if design is a concept, then drawing is the implementation of that concept. Design means something which is conceptual, which is there within our mind. And I have to discuss the same thing with my team, and I have to get that thing into shape. Whether that thing can be an aeroplane, that thing can be a bicycle, that thing can be a car or any other thing. So first, the concept has to be there. The design, in nutshell, we will take it as a concept. And how to implement that concept? The first process is drawing only. After you are done with the drawing, I have already told you, you are going to create the prototyping. For prototyping, we will use the SolidWorks software. A prototype is an early sample, model, or product built to test the concept process. This is the replica of the original model. And finally, the analysis part, where we will apply all the analytical tools and the basic science, mathematics, statics, and engineering fundamentals for the purpose of developing a product model that is convertible into the actual product. And this is how the whole process works. So as I have already discussed with you, there are three options. First is the drafting. I'm talking precisely about the process. The first is drafting, second is prototyping, and third is the analysis. When it comes to the actual software for the drafting purpose, the AutoCAD is the world leader. No question about that. Wherever you are working in this country, outside this country, where if you are working with engineer drawing, the best possible option available is the AutoCAD. But we can use AutoCAD primarily for the drafting. We can create the 3D within the AutoCAD. But primarily we use the AutoCAD software for drafting purpose only. After we are done with our drawing, we will go for prototyping. And SolidWorks is one of the best software we have for the prototyping. Means we have already the plan and we want to convert my plan into the 3D model, the replica of the original model. For that purpose, I will use the SolidWorks software. After I'm done with the replica, I will take that 3D model within the ANSYS software. I will apply all my loading conditions and the boundary conditions, and then I will analyze. If I will get the desired result, fair enough, go for manufacturing. And if I will not get the desired result, I will change my basic best possible solution. I will again go to the AutoCAD, make changes to the plan, done the same thing with my prototype in the SolidWorks, take that model into the ANSYS software, and this whole process will go on and on until unless I will get the desired result. So for that, these are the three different lines which you must be aware of. First is computer-aided design. Computer-aided design is the use of the computer system to access and create, modify, analyze, and optimization of your design. That is precisely what I am talking about when I am talking about computer-aided design. Is AutoCAD and SolidWorks. Means your drafting and your prototyping is actually the part of your CAD, computer-aided design. Then comes the CAM, computer-aided manufacturing, is to use the computer with the help of the conventional machines and to get the desired output. That comes from manufacturing part, comes under the manufacturing part. Maybe you have heard about this CNC machines, that is computerized numerically controlled machines. That is something which comes under CAM, sorry, computer-aided manufacturing. Then the third and the final step that comes under, that is the analysis part, that comes under computer-aided engineering, is to analyze the process. These are the three different lines which as a mechanical engineer I am supposed to know. At least one software per line I must be aware of if I want to excel professionally. For computer-aided design, the ones of the software you must know is the CAD and the SolidWorks, and for computer-aided engineering, you must be aware of ANSYS Workbench. And for manufacturing, we have a lot of other softwares, but that we will not discuss right now. Okay. Then that is our current topic today. We have to discuss about the SolidWorks. Okay. So this is the brief history about the SolidWorks now. SolidWorks Corporation is founded in December 1993. Basically, this software was founded by an MIT graduate, Mr. John, that released the very first version of SolidWorks, SolidWorks 95 in November 1995. But in the year 1997, Dissolve System, which is basically a French-based organization, precisely known for the CATIA software, acquires the SolidWorks softwares. Okay, right now, if we will talk about the SolidWorks software, that will be sold by this company, Dissolve System, which is a France-based company, actually a French company, which owns both the software CATIA as well as the SolidWorks software. And student, might be you are aware of the fact India has bought few of the Rafales airjet from a French-based company. This is the same company, Dissolve Systems, who are actually manufacturing Rafale airjets, and they are using this SolidWorks and the CATIA software for their in-house and prototype. So you can check out the proficiency of these softwares. No, about the SolidWorks, basically SolidWorks is a solid modeler software which use a parametric feature based technology which is initially developed by PTC, and the solid engines that software will use SolidWorks is using right now, that is para solid molding engine. What I mean by parameters refer to the constraints whose value determine the shape or the geometry of the model or the assembly, whether it is numerical or geometrical in nature. Okay, so let's say, for example, you have to create a knuckle joint as far as the SolidWorks is concerned. In the SolidWorks, we will go step by step. That the process is same. Whatever you are right now, you are seeing on your screen, the process is same for SolidWorks, for CATIA, for Creo, for and Autodesk Inventor. But right now we are talking about the Autodesk, so I will relate these things with the SolidWorks only. So if somebody will ask you to define what is the SolidWorks software actually is, so you can say SolidWorks software. In case of the SolidWorks, it's based on the feature. So feature refer to the small building blocks of the part. They are the shapes that and the operations that construct the whole of the part. Okay. So shape-based feature typically begin with a 2D or the 3D sketch of the shape, such as bows and the whole extra. Then the shape is extruded to add cut the remove the material for the part from the part. Okay, then we have different operation-based features that are not sketch-based, that includes the chamfers, shells, and we will apply draft to the face of the part. So in general, the design intent has to be there is to how the creator of the part want to respond to the challenges and the update. So just be patient. I will open the SolidWorks software and just a second. I will open the SolidWorks. If my SolidWorks screen is visible to all of you, if I can share it once again. In my SolidWorks screen, anyone, ma'am, Shivani, ma'am?
Yes, sir.
Thank you. Thank you very much for the update. Let's say, as I am talking about the SolidWorks software, this is my SolidWorks software. As you can see, this is the assembly of the knuckle joint. You can see I have created a prototype. This is not the actual knuckle joint. It's actually the prototype of the knuckle joint. That is a replica of the original model. So that right, this is our assembly. So when you go for the file, you click on the new. So as far as the new document is concerned within the SolidWorks software, you have the three options. You can create, first you have to create the parts within the SolidWorks software. That is what you mean by the feature-based modeling. Then you have to open the assembly modeling like this, and you have to bring the parts one by one and to assemble the complete assembly within this assembly, and then assembly mode. And then you will go to the drawing mode, and then you will generate all the dimensions of this assembly. Okay. So because you have to send this particular part to the product, the drawings of this particular part to the production department. Production department will work with the dimensions only. Okay. Okay. You can give the print of this one so that they can visualize the how the 3D part will look like before the actual manufacturing start. But they need dimensions. After you are done with your part molding, you are done with your assembly, you have to create the dimensions of a particular part and send that part to take the printout of that dimension and then give it to the production department so that they will start the production. Let's say I will open this particular part first. This is my fork end. So we will take it one by one. This is my complete fork end. Okay, this is not the original fork end that I have used the SolidWorks software to create the 3D model or the prototype. So let me share one thing more with you. So let me discuss one by one. First, so we see this is a 3D modeling software. Maybe if some of you have already done the AutoCAD software, you might be aware of the fact in case of the AutoCAD software, you can work only on XY plane. It is not practically possible for you to work on any other different plane like YZ or ZX. Okay, you can work only with one plane that is known as the XY plane. In AutoCAD, XY plane is also known as the construction plane. You can create whatever the sketch you want on the XY plane. And if you want to create the 3D with limited benefits or with limited probabilities, you can use Z as a direction of the extrusion. But that is not the case with the SolidWorks software. In the SolidWorks software, we have three different planes. Because it's a 3D modeling software, you can sketch your profile onto any 3D onto any plane, whether it is a front plane, top plane, or right plane. You can select any plane. Okay, you can see from here, you can select any plane and then you will start sketching. The first thing first, let's say for example, you have to create a whole shape like this. First, what you will do, you will go to the sketch and see here within the sketch. See here within the sketch, you have options like this. These are the same thing which you will learn in AutoCAD. Okay, the same line command, circle, spline, arc, slot, polygon. Then we have the trim, offset, mirror, and then we have the pattern. All those things we have already done with the AutoCAD software, and then we have to start with the SolidWorks software. So first thing first, when you are when you going to prototype any model within the SolidWorks software, you have to create a sketch. You have to begin with the sketch. And you have to make sure that your sketch should be closed one. Okay. First, you will create your sketch. Okay. Then the go to the feature. The very first thing you will select that is extrude boss. And then you will convert your sketch into the volume. Okay, I have created a sketch with two circle as 30 dia and the 60 dia. The dia of the inner one is 30. The dia of the outer one is 60. And whatever the extrusion I want the depth of this one has to be 22. I say 22. I have put the value 22 here and taken this direction as the mid plane so that it will have the 11 mm distance on this side, 11 mm this side. So when I click OK, this is my first prototype. Okay. So I will create the same thing. I will add on to features one by one. This is my first feature. This is my second feature. After that, I have created one of the plane. So this is my one of the plane at a distance of 18. So I've done this thing. I will go for the mirror command, and I have created a mirror of this one with respect to the center plane. I have selected the mirror option, go to the mirror. I go to the linear pattern. Here it is mirror. Go to the mirror, select this one and then select this plane. You have a copy of this. These are the two different features. So there is no such option in the SolidWorks software where you will create the entire model in a single go. Okay, you have to go by step. That is what I mean by feature-based modeling. In case of the feature-based modeling, you have to create the complete part one by one. What is the complete part here for me? That is the fork end. I want to create the prototype of a fork end, but there is no command in SolidWorks where fork end can be created with a single part. If that is the case, companies don't need engineers like us. They can simply click on that command and the complete prototype will be there. No, you have to create it step by step. You have to create the prototype by using the feature-based modeling. So after I'm done with this, I have created the part like this. Go to this one, go to the sketch again. I have selected the center plane. Within the center plane, I have created a sketch like this. So sketch like this. See, I have already the dimensions of this this drawing, this area. So I have created a sketch like this. Then I have clicked on OK. Then you go for the extrusion and whatever the depth you want. Okay, then click on this. Depending upon the right now, for me, for this part, the depth is 36 mm. Okay, you click here, the 36 mm is there. And then I have clicked on mid plane. Why mid plane? Because I want out of 36, 18 mm this side, 18 mm this side. After that, you will click OK. So this is one more feature. Okay. Then after that, I have created one more extrude here. Go to the sketch again. Within on the top of this surface, I have created a polygon. Okay. With 1, 2, 3, 4, 5, 6, 7, 8. 8 sides are there. Okay. So I'm done. Okay. Whatever the depth is given in the, as far as your dimension is concerned, select this, go for the edit option. Okay. So in that case, my total depth is 45 mm. I click OK. So finally, I will go for one more extrusion for, and then I will add filler to this. This is how I will create my entire forkant by using this feature-based molding. If somebody knows, if somebody will take your test on the SolidWorks software, and if he knows the SolidWorks software very well, he can simply look. This is our navigation bar. Okay. Within the navigation bar, we have all the history saved here. So the particular person who's actually taking your test on the SolidWorks software, and if you know the software very well, he can simply see here, see your history, whatever the commands, and just by seeing this thing only, he come to know whether you have created this prototype in the manner which it should be created or not. Okay, so this is my one part. I will click OK. Similarly, I will click yes. I will update my assembly, click yes. Okay, similarly, I have created a copy of this thing. Then I will select this one, this one, and I will select this one. I will click go. Okay, sorry. Oh, just a second. Not the same part. Close this one. So in that case, I will select this one. This is my collar. Okay, this is my collar. So this is only one part. I will select this. So this is my collar. So same extrude command and the cut command I have used. I will go for file. I will go for OK. I will show you all the parts one by one. Then within this part, we have this thing. We have the knuckle pin. Right click, click on this knuckle pin, click on knuckle pin. When you click on the knuckle pin is there. I have using the part molding, the solid molding interface to create all these different parts one by one. Okay. So go to the file, go to the close. The last part is your taper pin. Go to the taper pin, right click, go to the open. These are the 1, 2, 3, 4, 5. So I have created all the parts by using the SolidWorks part molding. I have created the prototype of all the parts one by one. After that, I will click on file. I will go for close. When I am done with all the parts, what I will do, I have to create an assembly like this. Okay. So I will close this thing. I will go to the file. I will go to the new. After I'm done with the parts, I will open the assembly, go to the assembly. After you are done with the part molding, you have to go to the assembly. Within the assembly, you have to go to assembly and then click on this, the part. What is the very first part you want to recall within your assembly? I will click on this thing. This is my first part. The first part is there. I will click OK. And here, student, you have to make sure that your first part will always be grounded. What I mean by this is very, very important. What I mean by grounded, because when you are going to manufacture anything as far as your physical world is concerned, in that you can in that case you exactly know the position of that model. But when it comes to the software, because you are doing everything online, it's actually in the virtual environment, So you don't know the exact position of this particular first part. So just right click this part and go for float if you are go for fix. I have already fixed it. When you will fix your first part, it means you have make sure its degree of freedom should be 0. What I mean by that, all the degree of freedom my this particular model is 0. See, as far as any of my model is concerned, we have 6 degree of freedoms, 3 translation and 3 rotation. When I have grounded my part, when I have fixed my part, I have make it sure all the 6 degree of freedoms of this particular model, 3 translation as well as the 3 rotation should be 0. And then I will create a complete assembly. I will assemble all the different models around this grounded part. So again, I will go for insert component. Right now I'm using the bottom up assembly approach. Again, I will recall one more part here. Okay. So what I will do after, see, I require these 2 parts has to be assembled with respect to each other. I go to the insert component, click on the insert component, use the bottom up assembly approach, recall all the parts. And after that, you go to the mates and you have to apply the constraint. What I mean by applying the constraints on the different model is to restrict their degree of freedoms. It depends whether you want all degree of freedom 0, you want to have 1 translation, 1 rotation, you want to have 2 translation, 2 rotation, you want to have 1 translation and 3 rotation, and depends upon you. It depends upon the kind of the part you are working with. Depend whether you are working with universal joint, whether you are working with axle, whether you were working with your connecting rod, camshaft, depending upon the part model you are working with and its position, type of the motion, sorry, type of the motion that model is using right now. So you will apply the constraint. But for this one, I will first apply the coincident. I want the central axis of this one and the central axis of this one should be, so it has to be concentric. So central axis of this one and the central axis of this one, I will just flip the direction. The center axis of this one and the central axis of this one should be in line with each other. Okay. So after that, see, right now I have constrained the motion of these 2 models. So see, in this case, the model will move up and down only. Model will not go to and fro. It will go up and down only because I have already applied a constraint. You will check out this thing. I have applied a constraint between these 2, that central axis of this one and the central axis of this hole will be in line with each other. No, what I want, the top surface of this one and the bottom surface of this one should be in line with each other. So what I will select this surface and okay, see, I will delete this one. I will clear this one. I will select this surface. Okay, I will select this surface on, I will select this surface. Okay, and the top of this one. Okay, so like this. I want to place, no, it has to be on the top only. Just a second. I have to select the surface like this one and this one. So it has to be placed in the center like this. So right now, see, I have constrained 1 more degree of freedom. Right now, the second fork with respect to the first fork can't move up and down, can't move to and fro, right or left. It can only rotate on with respect to its central axis. You can block this rotation also. You can block this rotation. You will expand the fork and 1 and select the central plane. Let's say I will select this central plane and I will open the fork and 2 and then I will select the center plane. I have make it sure the center plane, front plane of the fork 1 and the front plane of the fork 2 will be coincident with respect to each other. So when you will go for OK, you will see here what is there. It is fully defined. What I mean by fully defined, these 2 parts, these 2 fork ends with respect to each other will be fully grounded. They can't move. So when you will try to move or rotate any, it says the selected component is fully defined. It can't be moved. So it depends upon you. It depends upon your requirement of your design. You will decide whether you have to keep motion open or the totally closed one. So I have applied these 3 constraints. Then after After I'm done with these two fork ends, I will go for the insert component. I will click on the browse and I will click on the knuckle pin. You click on the knuckle pin, so you will bring the knuckle pin here. So again, I will go for the made. I will select the central surface of this hole and the center surface of this hole, this part. So I will select the lock rotation. Okay. So right now it will not rotate. It will go up and down like this only, up and down. But I want to constrain this thing also. So what I will do, I will select the top surface of this fork end and I will select the bottom surface of this knuckle pin and I click OK. As soon as I will click OK, see, it is fully placed here. It is fully placed here. And there is one more thing, student, if you can see, let's say, or let me open there is one thing. Let me open my just a second. I will open my collar here. Open your collar. What is the total depth as far as the collar is concerned? It's 15 mm. So see, whenever you are working with 3D modeling softwares like SolidWorks, you can't hide anything. If there is some problem as far as your part is concerned, and if you have not considered all those dimensions in the way it should be, so within the assembly you will come to know that there is some problem. See here, there is problem with the depth of the knuckle pin. No, knuckle pin has to be moved out of this one. The depth has to be more, so that I will place my collar pin and I will lock this thing. So in order to increase the depth of this one, simply select this one and then click on open. It will open your knuckle pin. It will open your knuckle pin. Within the knuckle pin, you go for the extrude. For this, I will simply select the dimension. Okay, simply select the dimension is 102. Okay, what is the total depth of my collar pin? It's 15. So I have to make sure it will be more than 15. So what I will do, I will change it to 120. I will increase the depth. So after that, you have to regenerate this one. Select this one. Select the knuckle pin and you have to regenerate it. You have to regenerate it. Okay. So no right in it. See the dimension. It's 102. I have just double click the dimension and change it to 120. That is what required by me. So that is what I mean by parameterization. Parameterization means all the dimensions are driven by the relation. If you can see there is some problem with your 3D model, no worries at all. Simply open that model, double click the dimension, change the value as per your requirement and click regenerate. It will regenerate your model and all the dimensions will be updated accordingly. After that, see, it's very, very easy. That's the beauty of the SolidWorks software. That's why we are using software like this. Okay, I go to the file, I click on the close. It says, you want to save changes to the knuckle pin? I say, yes, I want to save changes to the knuckle pin. When I click OK, because I am using the same in the assembly. He said, you want to update this thing in the assembly also? I say, yes, I want to update the same thing within the assembly also. See here. See here. Okay. After that, what do you have to do? Simply go to the insert component. Within the insert component, you have this collar. Just select the collar, click here. Okay. So here the collar will be. Then what do you have to do? So same thing. You will go for the made. Within the made, again you going to apply the constraint. I will select the outer surface of this knuckle pin and the inner surface of this collar one. Okay, I will click on the OK. After that, I will make sure the bottom surface of this one, the fork end, and the top surface of the knuckle pin has to be in line with each other. And you can also have to make sure see here, if you can see, so distance between from the distance of this hole from the bottom surface is something different, and for this is something different. So in that case, simply you will select this thing. You will select the knuckle pin. You will select on this thing, and you will just double click this one. Or you can go for the. You will open this one and see what is that. It has to be 7.5. The total distance is 15 from bottom. From this to this, the total distance is 17. It will be in the center, so it will be the distance from this point is actually 7.5. So you have to make sure. So you will go for the evaluate. First, check out the distance. I will go for me here. I will select this and I will select this. You will select both. The distance from the center to center is 3 mm right now. So 3 mm from this point and then 7.5 from this point, means total it has to be 10.5. So what I will do, I will check this one, this knuckle pin. I will open this knuckle pin. It will open the same part within the pod modeling. Within the pod modeling, you will select this opening for the knuckle, for the taper pin. Go and edit your sketch and check out what is the dimension. It is 15 right now. No, it should be 3 plus 7.5. 3 is the distance from the bottom of the knuckle pin and 7.5 is the distance of the collar from the bottom. So I will change it to 7.5 plus 3. It has to be 10.5. Change it to 10.5. Click exit. After that, simply regenerate. There is regenerate, yeah, rebuild. Rebuild your model. It will update the model accordingly. You click on file, click on first save, click on file, click on close. As soon as you will click on close, click on close, you will click on yes, click on yes, click on yes. Okay. Okay, see here. See here the students. I'm got the, see right now, wherever I want, it is there. The hole is there. But right now, the center line of this hole and the center line of this hole is not in line with each other. What I will do, again, I will go for the assembly. I will go for the mate. I will select this surface and I will surface this surface. And just simply, I will click on the lock location and I will click OK. So you will click OK, you will click OK, or you click OK. After I'm done with this, see here, both of these two holes are in line with each other. So this is the beauty of the 3D modeling softwares like SolidWorks. If you want to create something like this assembly like this in actual environment, first I will use the SolidWorks software to create a prototype of this 3D model. And whatever the problem I will going to face, I will clarify all those problems within the SolidWorks only. If there is some kind of clash detection, if there's some kind of interference, if there is some kind of problems with the dimensions, each and everything I will rectify within the assembly itself or the pod molding itself. In the end, I will go for the insert only. I will select the taper pin, click the taper pin. The taper pin has to be there. Just select the taper pin, go for the mate. After go to the mate, simply select this taper pin and select this one. Select this one. Okay. So I click on the lock rotation, click OK. So you can also you have to flip this one. Just a second. You have to flip to change the direction. Simply select here, click on mate. I will go for the concentric mate again, open my mate again, and I will go for the flip like this. Click OK. So you can place your taper pin. Then you will go for this plane to plane mate and it will fix your tangent fin. This is how you will create complete assembly within the SolidWorks. This is a process. First, you have to create the model one by one. After you're done with all the models, you have to bring all the models within the assembly, apply the constraint on those models, and then assemble all the models together within the assembly. And after that, when you are done with this thing, simply go to the file, click on new. Within the new, go for the drawing. Click on the drawing and click on OK. As soon as you go to the drawing, you click on OK. You have an entire page there. Okay, click OK. Within the entire page, simply you go to the browse. Let's say, for example, I will select my fork end. I will select the fork end. I will place. No, it depends upon you. Whatever the view, first view you want to place, or you want to place a multiple view of the same part. So same model. So I want to place the multiple parts. I will click on the create. The front is already there. Then the top, then the right. And if I want the isometric also, then click on the isometric, click OK. On the drawing sheet itself, it will generate all the views for me. So that's the beauty of the software. Within this, just only by a click of the mouse, it has actually generated all the different parts for me. If you want to see the precisely this one, the isometric view of the fork on the paper itself in solid molding only, just click on the shaded option. You just click on the shade option, click OK, and it will convert your wireframe into the solid. After that, what you will do, you will simply go to the annotate. Within the annotate, you go for the smart dimensioning. Within the smart dimensioning, whatever the dimensioning you have to generate, simply click on that and generate the dimension for yourself. Because the production department will ask for the dimensions. Now, whenever you're going to manufacture something, you need dimensions for that. So production department will ask the dimensions. Now, sir, we need the dimensions. So you have to create the dimensions, dimensions for the complete part. Just click anywhere you want, and it will generate the dimensions. Then I will come on in this view. I will create another dimension like from here to here. From here to here. Okay, from this side, I will click this one. So we have the dimensions like this. So wherever you want to place it, what is the total width, the depth? I will uncheck this. I will go for the smart dimensioning here. Just I will click this and I will select this one. This is the dimension here. So the company asked me what is the dimension between this and this. I will go for the annotate again. I will select this edge and I will select this edge. Go for the annotate again, select this edge and then select this edge. Here is my dimension, whatever the dimension. Whatever the dimension that is required by the engineer or production department person to manufacture this thing, I will first create a drawing view of that model, and then I will generate the dimension so that the person should know what is the exact dimension as far as the manufacturing of the whole of the part is concerned. This is so. And you can also do one thing. You can simply go to the file. Let's say other guy will ask you, Mr. Balaji, I don't have the SolidWorks software. Okay, I have only the AutoCAD software. What I will do? You say, sir, no problem at all. You have the AutoCAD software. What I will do? I will generate the complete drawing view within the SolidWorks software. I will generate all the dimensions for you. And then what I will do? I will go to the file. I will click on the save as. Click on the save as. Within the save as, you have an option like DWG. You will save this thing in DWG here. See, save this thing within DWG only, not as a SolidWorks drawing file. Save it as DWG only and click on save. Then you will send this file to another person. If the another person is having the AutoCAD software, okay, he will simply double click this file, and because this file is DWG only and the file extension for the AutoCAD software is DWG only. So the same drawing consisting of all these models with all these dimensions, he or she will be able to open within the AutoCAD only. Also, and you can, if you want to see the section view of a particular, you can generate the section view also. Simply, I will delete this one. I have a model like this one, so I will go for the drawing. Within the drawing, we have the section view. You click on the section view, and whatever, see, you have to just select the cutting line. You want the cutting line should vertical, horizontally, aligned, auxiliary, depend upon your requirement. So I will just simply place the cutting line here, click OK, and I will generate my view. So I will go for the section view. Simply place your cutting line horizontally. Just click OK and place your section view. You can cut your 3D model along horizontally, along vertically, depends upon your requirement. This is your solid view. I will simply just move that view across here. What I will do, again, I go for the section view. I want to see the inside of this one. I will go for the section line as vertical, place a section line here, and I will click OK. As soon as I will click OK, it will place a section view. This is my complete original view, and this is the section view. Depend upon your requirement. If you have an assembly and you want to see the inside of the assembly, you can also go for the section view within that. So finally, to sum up, I will open few more assemblies for you so that you will have a fair idea. Like we have this plumber, we have this stall wall. I will open the assembly so that you can see the complete assembly. So these are the, see, so limitation is not from the software side. So limitation is from the user side only. It depends upon whether one spindle is missing in this case, whether as a user you know how to use the software or not. See, before actually manufacturing this whole of the assembly, this assembly of the stop valve, this so what I will do, I will use a 3D modeling software or prototyping software like SolidWorks. First, I will create all the parts one by one. Then I will assemble all the parts together within the assembly. And I will check out within the assembly only if there is problem, there is any issue as far as the dimension is concerned, as well as the placement of the model is concerned. I will rectify that within assembly only. And then I will start the manufacturing. It will reduce the losses, the amount of the losses the company is going to incur. In the long run, it will reduce the losses for the company and will increase the profitability of the company. And right now, the companies are also looking for those engineers who must have the knowledge of these 3D modeling softwares, because this is the future. These softwares are the future. These softwares are the way forward only. So only engineering degree or diploma will not fetch you a good job. You must have the knowledge of 3D modeling softwares like this if you want yourself to be working with one of the top shot companies in the long run. Okay. Am I clear to everyone? Ma'am, should we open the session for everyone? Let anybody have any question, they will ask. Hello.
Yes, guys, any questions?
Yeah, if they can put in the chat board if somebody will have any answer. If somebody will wants to ask any question related to the current session, if you have any door regarding the SolidWorks. Yeah, you can have the gear assembly. So it's not like, see this particular software is for everything. See, as a user, you have to decide what kind of the assembly you want. As I have shown you. So let's say I will show you one more assembly. We have this knuckle joint assembly. We have this. So you can create. It depends upon the user. As I have shown you different kind of assemblies. This particular software is not only for one of the things, like you can design the gear assembly here. I can design the car here. I can design the mobile here. I can design the bicycle here. You can design anything. Okay, that you can. Can you? The question is, can you can have the any gear assembly? Yes, we can have the gear assembly. You can prepare anything. Right now, I don't have the gear assembly with me, but you can create any assembly within the SolidWorks software is concerned. The question from Mr. Ramesh, can we prepare all the components in a single file? No, not in a single file. See, as far as the assembly is concerned, we have two kind of approaches are there. One approach is when you go for this insert component, you have two approach. One is insert component, and second is the new part. If you go for the insert component, which I have shown you right now, it means you are using bottom-up assembly approach. We have one bottom-up assembly approach and we have one top-down assembly approach. As far as the bottom-up assembly approach, the process is like, yes, the process is like this. You have to create all the parts in a single file and then recall all the parts within the assembly and then use the mates and apply all the mates in assembly one by one, considering the degree of freedom of all the parts, and complete your assembly. That is your bottom-up assembly approach. For your top-down assembly approach, this is how you will create all the parts within the assembly itself. You will create the new parts on the top of the existing part. For that, you go to the insert component and you click on this new part option. Within the new part, you can create all the parts to one by one within the assembly workspace itself. So I hope, Mr. Ramesh, it is clear to you. You can use, if you want to create all the parts all together in a single file, then you have to use the top-down assembly approach. And if you want to create all the parts one by one and then assemble it by using the constraint and depending upon their degree of freedoms, then we will use this bottom-up assembly approach. I hope I'm clear. Thank you. Thank you. No, it's not like that. MV sir is there. He's asking, is SolidWorks is necessary for learning CATIA? Student, here is one more thing I will tell you. You can learn only one software, but it's like Digna, if you want to go into the market and you want to increase your job probability, and if your financial situation allows you to go for number of software, you can learn as many as softwares you want. I have done post diploma in CAD/CAM technology way back in 2004 from NSS in New Delhi. Okay, at that time, I have learned AutoCAD, I have learned CATIA, I have done SolidWorks, I have learned Autodesk Inventor, I have learned CNC programming also. So what happened in that scenario? If some company is looking for a guy who knows the SolidWorks software, I can apply. If some company is looking for a guy who knows this SolidWorks CATIA software, I can apply. If some company is looking for a guy who knows this Autodesk Inventor, I can apply. So this that gives to the leverage over another guy, but it's not actually necessary for you to learn the SolidWorks software. SolidWorks is necessary for learning the CATIA software because the basic terminology as far as the CATIA or the SolidWorks software is concerned, both are same. Only the mode of implementation is different for both the softwares. But if you know more softwares, that it will increase your uh, probability of getting the job in the market. I hope I'm clear. Anybody else, students? Other than that, I will wind up the session. And it's a humble request to everyone. Please fill up your feedback forms. Shivani ma'am, is there anything from your side?
Yes, sir. Yes, sir. Guys, any more questions? So there is one announcement. We have our new batch on April 23rd, 2025. The session is totally in online mode, and we have been providing 100% placement assistancy. The course duration is 60 working days, and it is paid course. And already I have been shared all the details in the chat box. Interested students kindly fill the sheet. And regarding fees and everything, our team will approach you. Okay. Yes. Is there any doubts?
See, the basic difference between SolidWorks and Creo, first, both are from the different companies. SolidWorks is from the Dissolve System company, which is basically a French-based company, and the Creo is from the PTC Corporation, that is a USA-based company. Okay, but having said that, we use SolidWorks and the Creo precisely for the prototyping only. I have already told you, whether you are using SolidWorks software, CATIA, Creo, or the Autodesk Inventor, the mode of application is different, but the basic consensus behind the software is same. We are using Creo for, and one of the most important things, student, I will share with you. See, every software has its own USP, unique selling point. When it comes to daily normal day-to-day engineering products, SolidWorks is the best software, by far the best software as in the market. But when it comes to the hardcore solid modeling, Creo is the best software in the market. When it comes to the complex surface modeling, like you want to develop any aeroplane, a fighter jet, an automobile, like a car or something, like where there is much of work as far as surfacing concerned, CATIA has no competition at all. Okay, so it actually depend upon the company. Why the company, for which purpose the company is using that software. If that company is into the manufacturing, in solid molding, the company will use, the person, he or she will use Creo more for that purpose. But when it comes to the normal day-to-day engineering products, for that, everyone is using SolidWorks software. It's the prime software for that across the all the organizations available in the country. When it comes to the surfacing, CATIA has no competition at all. So service software is beginner friendly and also easy to navigate. By far, SolidWorks is the best software and very easy and very user friendly software. But having said that, CATIA is a more complex software to learn. But where you can use CATIA, there you can't use any other software. So CATIA has its own selling point. But when it comes to the beginner kind of software, and you can say very easy to learn kind of software, and which is more user friendly, and on top of it, more companies are using also the SolidWorks software. Say if you have already done the SolidWorks software, your job, the probability of getting the job into the market is increased by many folds. So precisely answer to your question, which software is the beginner friendly and also easy to navigate, it's by far the SolidWorks software. And SolidWorks software has the highest users across India. Thank you, Parveen ji. Thank you. Anybody else? Any doubt? Shwani ma'am, then we will wind up the session.
Yes, sir. Yes, sir. Yes, sir. Thank you for your valuable time, sir, and thank you for your nice session.
Thank you, ma'am. Thank you, ma'am.
Yeah,
Thank you.
sir.
Thank you, HIE, for this particular session. And thank you to all the students for your patience learning. Thank you. Thank you very much. Thank you.
Thank you, sir. And
Thank
thank you, guys. We will meet on Monday. Okay. Thank you. Bye.
Just a minute, ma'am.
Yes, sir.
Mr. Ramesh is asking, sir, very informative session. Please tell me the difference between parametric and model. See, the question should be like, what's the difference between parametric modeling? Parametric modeling means if they see, as I have already told you, now as we have seen in the last assembly, the dimension has to be 10.7, but it was 15. So there is something wrong with my dimension. I have just opened the 3D model. I have just double clicked the dimension 15. I have changed the dimension from 15 to 10.7. I have just clicked the OK, save, update it, saved it. And my existing dimension 50 got changed from 15 to 7.5. Sorry, 10.5. So this is what you mean by parametric modeling. Oh, it's a feature-based modeling. Okay. Feature-based modeling, let's say I have to open, let's see, just a second. I will open this part. Open this part. If you are able to see this part, just me open this. So, okay. Open this part. You can see this thing now. These are the commands which I have used. First, I have used the revolve command to create the thing like this. Then I've used the solid extrude cut, mirror, and all those options one by one to create a complete part like this. This is what you mean by feature-based modeling. Feature-based modeling means you will these extrude, this revolve command, extrude command, the mirror, the plane, the extrude, the cut, and so on. All these are the features, and I am using these features one by one to create my complete part like this. This is what I mean by feature-based modeling. Means I don't have any option within the SolidWorks software to create this complete 3D model in a single go. There should be a command like this. I will click on that command, and the body will be there. It's not like that. If you want to create a complete body like this, you have to create one feature one by one. First, you have to create the base feature. Then all the features will be created in and around the base features only. And parametric modeling means when you will, let's say, for example, I will click this one. I will go for the edit. Go for edit. In this case, if I want to change the angle, let's say I want to change the angle from 360 to 180. So it got updated. That is what you mean by parametric modeling. What parametric modeling means, dimensions are driven by relation. Whenever you will change any dimension, it will simultaneously it will update your 3D model. That is not the case with the AutoCAD software. In AutoCAD software, every dimension is an individual dimension. That's why we are not using AutoCAD software for 3D. We can use AutoCAD software for 2D. Okay, sir. Am I clear? Thank you. Thank you very much. Over to you, Shivani ma'am.
Yes, sir. I think there is no more questions from anyone.
Yes, ma'am.
Sir, can we end the session?
Yes, we can end. I'm extremely thankful to all of you. Thank you for your valuable time. Thank you.
Yeah, thank you, sir. Thank you. And thank you, guys. We will meet you on Monday. Thank you.
Thank you.